This is lecture number 1 of the course AU 203 Statistics and Quality Control. This is in this lecture we will just introduce the subject of statistics and quality control. We have already gone through with the introduction of the course, and we already have learned the course content. So we will begin this lecture with what statistics is all about, and then we will go into the defining quality and what are the factors which actually taken into account in quality controls. And then we will look into popular 7 QC tools, what you call it, quality control tools, just their names, not in the detail. And then we will look into the idea about ISO 9000 quality management systems, or sometimes called as ISO QMS. And then we will start the subject of statistics by going into what is meant by population and sample. And then we will look into the branches of statistics, what part is descriptive statistics and what part is inferential statistics. And then we will look into the types of the data, what is meant by univariate data and what is meant by multivariate data, and then we will group the data into group form, and that is actually we can develop the frequency table. So this is the lecture content. So when we look into the word statistics, there are several interpretations and several meanings comes, and immediately the word which comes into the mind is data. And obviously the collection of the data and making certain predictions about the data, if and organizing the data and performing an experiments, and all these things comes into the subject of statistics, especially about the probability as well as the distribution of the probability. So the subject of statistics can be defined as the science of collecting and analyzing data. So you're not just collecting data, but you need to analyze data in order to bring the data into more meaningful form, from a raw data to the refined data. And refined data is something which allows you to analyze. So in statistics, obviously, once we are collecting data, then we need to visualize the data, and there are different tools available to visualize data. And these tools are very handy, and graphing tools, and in this course we will learn several tools for analyzing data through graphs. We can say that statistics is actually not just analyzing the data, but actually we are more largely dealing with the random data. So any number can come in as a data. And for example, if we are interested in the height of the people, then every individual would have a different height, or even some might have the same height, but there is always randomness associated with the data. So what statisticians are working on, they are not just working on the data or analyzing the data, but they need to look into the randomness of the data, and they have to understand how much is the variation taking place in the data due to certain factor or due to the randomness. So the whole subject built around it, and we are interested in understanding understanding and analyzing the data in a manner that how much is the contribution of randomness and how much is the contribution of the factors which are actually affecting data. For example, if we are dealing with the height of male and female, so we will find there is a difference between the height of the male as well as the height of the female. So height of the female is average height of the female is always less than the average height of a man. So it means we need to group data into different parts, different groups. So male is another one group and female is another group. But within this group of female, there is a randomness associated. So different females would be having different height. Similarly, different males would be having different height. So the whole subject is dealing with how much is the difference in the height is due to the gender, or it is due to the randomness. So the whole thing builds around it, and this subject gives you an insight and allows you to make intelligent decisions, and or what you call it a data driven science. So in modern day in computer science, the data science has emerged as a separate discipline, and where statistics play a major role. Okay, so when you talk about data and you talk about statistics, so you are interested in different distributions, how the values are grouped together. And for example, if you are in a manufacturing industry, then you know there is some nominal value, and there is some lower limit, and there is some upper limit, and your observations or your samples would come into that limit. So this is actually a representation of a control chart. So in this subject, we are not just dealing with statistics and probability, but we will be dealing with the statistical process control as well, in which we are required to develop control charts. And in the later part of the course, we will go into the detail of the control charts. Right now, we're just talking about the length and breadth of the subject. So, and we will be interested in improving the quality of the product or a service as well. So, and then this question comes about what is actually quality. So, what quality means is different people have different perception about quality. So sometimes some people says that it is actually delighting customer happiness. So once you customer receives a quality product or a quality service, then obviously the customer would be the happy person. So this can be taken as a customer satisfaction could be one of the criteria for a good quality product, or some measure of excellence in the product, comparing with some standards. Some products which are good for the use, and they always survive and they doesn't fail. So this could be another aspect of quality. And sometimes we have look into the imperfections and contaminations and defects. If your product is free from all those defects and imperfections, then we call that product to be a quality product. Or sometimes we say the totality of the characteristics that is actually that given product or service should bring that satisfaction level, and if overall it is doing its purpose, then we call that product to be a quality product. And sometimes we defined quality is actually the conformance of the requirements. So you have certain specification of a product, and if your product is meeting that specification, so it is conforming to the requirement, so we call that product to be a quality product. So there are different definitions there. So one of the definition is, which is related with customer satisfaction, is if there is a quality product, then it means such a product is capable, such a product or service, it is capable of satisfying the customer requirement. So ensuring complete customer satisfaction is the feature of a quality product or a quality good. Sometimes we are interested in the totality of the features and the characteristics of a product, process, or a service. So it could be a quality process as well, which is the most efficient, which and we will look into the definition of the process in the later part of the course. By the way, the process is some procedures from which you convert your input into output. And input is provided in the form of the raw material, and output is in the form of a product which customer get in the end, and that satisfy the need of the customer. So what all these quality products have satisfying the customer requirement, as well as it serves the purpose for it is meant for. So once the product is doing that, then we call such products to be quality product. There is an organization called ISO, and ISO defined quality as degree to which a set of inherent characteristics fulfill requirements. So it is actually degree. It means it is a measure by which we check that whether the given product or a service meeting the requirements. So there are certain features of the product which satisfy the requirement. If it is fulfilling, then that product would be called as a quality product. Or in short, if you don't remember any definition, just keep in mind that quality means conformance to the specifications. So whatever the specifications are that a given product is required to serve its purpose, and under given conditions, if it is confirming, then that product would be called as a quality product, or service could be a quality service, or it could be a process, we call it a quality process. So quality, the sense of quality means conformance to the specification actually. In quality control concepts are evolved over the years, starting from Industrial Revolution, and Japan is known for its quality products, and Japanese philosophy has taken some few basic tools, and sometimes they call it 7 QC tools, quality control tools. So one of the tool is a check sheet. So whatever you are producing, whatever you are doing, is it has certain, that product has certain features, attributes, and these features you just check whether they are performing it or not, and how many of those numbers which are performing the given quality, then it comes into the form of a check sheet. So the check sheets give you an understanding of whether you are meeting the quality or not. Sometimes in a process you need to understand the process. So how you are producing a quality product is aligned with the flow chart. So what processes you are taking in, what are the conditions, and all these things. So if you understand that, then you will be able to understand the quality as well. The third chart, which is actually called as a Pareto diagram, and this Pareto diagram actually tells you something about which particular feature is something more dominant and which are less dominant. So more dominant features to be addressed first, and less dominant feature to be addressed less. So such a diagram is actually called as Pareto diagrams. And then you have histograms to get some understanding of the distribution associated with a particular characteristic or attribute of a product or a service. So we represent it by histogram. So don't worry about at this stage what these quality tools are. Several of them we are going to study, we will study it during the course. Another type of diagram which is called as a fishbone diagram, or cause and effect analysis. So you look into more closely. If you, let's say, in your production facility you are not getting the required quality level, then you look into closely what are actually the causes, and what are the factors which are responsible for that non-conformance, or not meeting the requirement, or having defects in the product. So you draw such diagrams which are called cause and effect diagrams. So the main line is actually the central part of the fish, and the other lines actually called as bones of the fish. So that's why it has been given a name as fish bone diagram. Okay, and another tool that is available is actually called as control charts. So you analyze it statistically whether your process in control or out of control. Within the limits, what is the behavior, how much is meeting the average, or the central line of the control chart, or how much is away from the central line. So all this one can analyze through these control charts. There is another technique which is called stratification, and stratification means you make sure that your observations are following certain behavior, and one can graphically plot such behaviors. If x-axis there is some quantity, y-axis there is some quantity, and You want to relate if you changes x, how much would be the change in y. So you need to draw scatter plots in order to get this correlation. So whether x and y are correlated, it is positively correlated or negatively correlated. For example, if increasing x, that increase y, it means it is linearly increasing or linearly decreasing, or there is some trend line or whatever the changes come into the data. So that can be done, and we can treat the data into different strata or different groups. So that technique is actually called as a stratification, and scatter plot is the tool which is used to classify different variables which can affect the quality of a product. So these tools are called as, in general, 7QC tools, and in the later part of the course we will deal them in quite in detail. Okay, ISO 9000 is actually a quality management principle which is actually having so many components involved. So, where we are focused on customer, where we are engagement of the people in improving the quality, and we improve the process, and we look into continuous quality improvement, and we make decisions based on the data and evidences which you get it from different measurements. And then we need to improve the teamwork in the production team as well as with the other teams. So there is some relationship management, and obviously there is a big role of a leadership of an organization which is more conscious towards better quality and higher quality. And so all these different organs actually usually a part of quality management system. And the purpose of all these things are to improve the process, improve the quality, and perform the continuous improvement strategy. So this comes under this, and ISO has several standards for different activities ranging from production setup to energy management setup to any setup. So there are several different standards for ISO 9000 come under the category of ISO, and they are available, and they have different nomenclatures, but largely they are dealing with all these organs where leadership need to play a role, focusing on the customer and improving the relationship between workers and staff and management, and have a sense of continuous improvement by every individual of the organization. So all these things comes into the so-called ISO 9000 quality management system. By the way, NED also ISO certified for about more than a decade, and they are following certain QSPs and quality system procedures, and they are following certain policies, and you look at as a quality policy or the vision of the university, and then the university mission and all that. So and we have all the documentations available how to do this process, whether you are purchasing anything, whether you are asking for academic services and all that. So different organizations have their own quality management systems and their policies. Okay, now come back to the subject of statistics. There are two terms which are very important to be understood well right from the beginning. So, for example, if any parameter or any characteristic we are interested in, for example, we are producing, let's say, shafts, and there are 100 shafts are produced in a day. So, and we are interested whether the shaft produced are meeting the specification or not. So, what we need is we take a small sample out of those shafts, and we check whether these samples are meeting the requirement or not. If the samples meeting the requirement, then we can infer about that all the shafts produced in that day are meeting the requirement. So, sample is always a subset of the observations you take from a larger set, and the larger set would be called as population, and a subset of that smaller set, which is a subset of that larger set, is called a sample. So, once you have a population doesn't mean people, it could be population of any shaft, or it could be anything, and you can take a few items from the population to make it a sample, and from that sample you interested in the characteristic or the behavior of the population. So the term population and sample, we will be using it quite a lot in that course, and one must be very good at understanding all these. Okay, the subject of statistics can be divided into two parts. One is called descriptive statistics, and other is called inferential statistics. So, in descriptive statistics, we are interested in analyzing the data and visualizing the data, and we are interested in the central tendency of the data, where the most of the data lies. Central tendency means where most of the data lies, or we are interested in how is the spread of the data. For example, the example of a height. So we say most of the people, most of the men of a particular, let's say, group, like college, then their height is in the order of 5 feet 8 inches, something like, might be, that would be an average height. But the same average height is smaller in females. So that actually represent the central tendency of the data. But some heights could be smaller than 5 feet 8 inches, maybe 6 feet 4 inches, 6 feet 3 inches. So these would be the extremes of the data, which is not the central tendency of the data. Or might be, some might be much shorter, and their height could be 5 feet. So the dispersion of the data represents how the data is being varied. So all such studies actually bunch into what people call it descriptive statistics. Second part of statistics is called inferential statistics. So in inferential statistics, what you need is you need to predict the behavior of a larger set, which you call it a population. So population has certain features and certain characteristics. So what we do is we take a sample, and that process is called sampling. So out of that population, you cannot investigate each and every individual of the population, but you can investigate or analyze some part of that observation. So we call that to be sample. And from that sample, we make inferences, prediction about whether it has certain features or not. So this step is called inferential statistics. Obviously, inferential statistics requires knowledge of sample statistics, like you need to know the average central tendency of the measurements taken for a sample, and you need to know the dispersion as well. So all these things would be required even in inferential statistics. But in inferential statistics, there is always a term called sampling, and we need to predict the behavior of the population through a small subset, what we call it a sample. And the sample is supposed to be the representative of the population. Okay, there are a few more terminologies here. What you call it a variable. Variable is the characteristics, obviously, that is changing. It could be changing over time, or it could be changing from one person to another person, or one object to another object, whatever it is. So it means it has the ability to change. So that thing would be called as a variable. For example, height of a school children, body temperature of a person, or number of offspring in a particular family, or number of defective parts produced in a batch or a lot. So all these things would be changing from day to day. They would be changing from machine to machine. They would be changing from person to person. If you're talking about the temperature of a person, it is not the same temperature by every individual. or it would be the number of offspring in a family. So all these things are varying. So these features or characteristics would be called as variable. These data always comes from some experiment, and we perform an experiment. For example, it could be a simple experiment like tossing a coin. So your outcome could be either head or it could be tail. So your options can vary, either head or tail or one or zero. And so this tossing a coin would be called an experiment. And an experimental unit would be called as a particular individual or an object to which a variable is being measured. So that is called as an experimental unit. For example, in the example of height of school children, so the children would become an experimental unit, and the height would be a variable. So once you make it a single measurement or data values which represent variable, when a variable is actually measured on an experimental unit, so you call that to be a single measurement. So for example, a set of 5 students is selected from an undergraduate at a large university, and measurements are shown below. So what we are doing is we have the population of undergraduate students at a big university. So there are a lot of students studying in that university. So what we are interested in, what we have done is we have only selected 5 students out of all the undergraduate students in this university. So we call student 1, 2, 3, 4, and 5. So what we do is so the student becomes an experimental unit, and we perform certain measurement on that experimental unit. So we are interested in the GPA of a student 1, 2.3 is the GPA of a student 2, and so on. We would be interested in a variable called gender, whether the student is female or whether it is male, or we could be interested in whether the student is from first year or second year. So first year students are called freshmen, second year students are called sophomore, represented by letter SO, and FR for freshman, and third year students are usually called junior, and final year students are called senior. So in NAD we have this FE, SE, TEB students. So but in America you could have classifications like freshman, sophomore, junior, and senior. So here there is no senior student is chosen in that 5 student sample. So the question is, what is actually what are the variables which are involved? So here for an experimental unit, 4 variables are involved. For example, GPA is one variable, gender is another variable, and the year in which the students are studying is another variable, and the major subjects these students have taken. For example, student 3 has a major in English, or student 2 has a major in mathematics. So there are 4 variables involved here. And then the undergraduate students is actually your experimental unit. So having 4 variables, and how many measurements we have taken. So we have for each variable like GPA we have 5 measurements. So measurement is actually the data or value that comes for a variable when actually a measurement is performed in an experimental unit. So once we calculate this 5 measurements, so we have found the GPA of each and every 5 students to be recorded. So there are 5 measurements for each variable, because there are 4 variables. So altogether 5 multiplied by 4, there will be 20 observations altogether for these 5 students, because there are 5 students, 5 measurements, and 4 variables involved. So 5 into 4, there will be 20 measurements altogether. So for example, a measurement of an experimental unit, that is student 2, we can write like this, having a GPA of 2.3, gender is female, the year is sophomore, and the major is mathematics. So this represent the data for one of the experimental unit, and there are four variables involved. You know. So if the number of units are five, and for each student we have four different variables to be measured. So altogether we have five different measurements for each variable. So altogether there would be 20 measurements. In statistics, obviously, we are dealing with the data, and the data can be qualitative or quantitative, and quantitative data could be discrete or continuous. So sometimes a term used which is quantitative data is actually called as variable. Sometimes it is also called as variable, and qualitative data is sometimes called as attribute. For example, if you are interested in color of apple, so it could be yellow color, it could be green color, and this color is actually a qualitative characteristic of apple. So it is not quantitative. But sometimes your measurement in quantitative, then you measure it quantitatively through numbers. And these numbers could be either a countable numbers, or either it could be a continuous numbers, like measurement involved decimal point, something like that. So qualitative variables are measure a quality or characteristics on each experimental unit. So these are called qualitative variables. Quantitative variables are usually measure a numerical quantity, and there is an amount associated for each experimental unit. So such variables are called as quantitative variables. And further, this quantitative variables could be a discrete variable. Once it is discrete, it means either it is finite or it is countable. It could be 5, it could be 6, it could not be, I mean, for example, if let's say there are 5 people watching particular movie, or 4 people watching, so you cannot say 4.5 people watching. So it is something that variable would be called as quantitative, but at the same time you can only count, it would be called as a discrete variable. And then there is another type of variable which is called continuous variable, which have the values, infinitely many values corresponding to the point on a line interval. So a measurement from 1 meter to 2 meter would be involving 1.1 meter, 1.2 meter, 1.5 meter. So infinite number of values will be available in that line interval. So that variable is called as continuous variable. Okay, and then there is a terminology of data, what you call it a univariate data and multivariate data. So univariate data results when a single variable is measured on a single experimental unit. So that terminology is called as univariate data. For example, when you measure the temperature of different people, and the resulting data is called univariate data, in a sense that you are dealing with a variable which is temperature, and your experimental unit is 148 people, so, or a group of people. So what you are doing is you are interested in a single variable, and your experimental unit is on a single experimental unit. So it means the group of people you are interested in measuring the temperature of the body. So that data, if you generate that data, so you need to take a lot of measurements, 148 measurements for each experimental unit, means for each person. And your variable is a single variable. So once you have a single variable and single experimental unit, that set of data is called as univariate. So in the previous example, as you see, when you are dealing with two variables for the same experimental unit or a single experimental unit, such data is called bivariates. For example, if you are interested in the temperature of the people as well as the heartbeat of the people, so there are two variables, you are dealing with the same experimental units, then it would be called as bivariate data. Previous example of five students having involved four variables, that was an example of more than two variables. So we call it a multivariate data. So we have the same experimental unit that the group of students, but we will be dealing more than two variables like GPA, like year, like so major, and once we are dealing with all these different variables, then it is called as a multivariate data. So these are just the terminologies. Univariate, so it means you are only interested in a single variable of experimental unit. In bivariate, you will be interested in two variables of the same single experimental unit. And in multivariate data, you are interested in more than two variable. So in reality, most of the time you will be dealing with multivariate data. There is a problem from this. Let's say you have six vehicles are selected from the vehicles that are issued campus parking permits, and the following data is actually recorded. So, for example, six vehicles. So there are one vehicle, two vehicle. There are six vehicle, and the type of the vehicle is there, the make of the vehicle is there, and the carpooling. Carpooling means actually the car sharing, whether such a car is used for car sharing or not. So this carpooling is not common, but it is very common in advanced countries, where if you're moving from one station to another, you allow other people to join your journey, and this is called car sharing. And then you will be interested in this vehicle which is actually traveling how much distance in one way commute. So let's say 23.6 miles, and the another variable that is involved is the age of the vehicle, which is given in years, and how old is your vehicle. So this data set is given, and what we are interested in this problem answering, what are the experimental units. So you need to find out what are the experimental units. So at this point you need to pause the video and try to answer what are the experimental units involved. Okay, so experimental unit is vehicles. Vehicle is a group of vehicles, and we have selected only six vehicles. So in this problem, experimental unit is vehicles. And then the question comes, what are the variables being measured? So try to answer that question by yourself by pausing the video, how many variables you are dealing with, and let's see how many do correct answers. Okay, so we are dealing with five variables like type of the car, make, whether you're doing carpooling or not, one-way commute distance, and age of the vehicle. So this is your five variables involved. Okay, the next question is this data univariate, bivariate, or multivariate? So univariate means you have a single variable for a single experimental unit, but here your variables are more than one, more than two rather. If it is two, then it will call it bivariate. So here you are dealing with as five different variables, so that essentially would be called as a multivariate data. So these are the terminologies: univariate, bivariate, and multivariate. Okay, another aspect of the data is what you call it a grouping of the data. For example, in this problem, you have a survey taken from a public education, 400 school administrators, and in United States, and there was certain rating is actually recorded. So rating A, rating B, rating C, rating D. So and their responses of the survey is summarized in the table, what you call it a frequency table. So you see there were 400 responses are collected altogether, and 35 of them has given a rating A, 260 has given a rating B, and 93 has given a rating C. So what we have done is 12 12 administrators says that the education system in United States has a rating of rating D. So and what you see from this data is making sense of that data. So data is just the numbers which are given, and here the data is given, but this data doesn't make sense. So what we do is we process that data. Let's say I draw the bar chart, and we see the tendency for rating is 260 people, lot of people, 260 people given the rating B. So most of the people, administrators in the survey, has rated the United States education system with the rating level of B, and few given the C, and very few given D and A. So this distribution of the data gives you more meaning. So the central tendency of the data is towards the rating B, and few people grade it as A as well as D. So once you plot the data, this numbers just turn into making more sense out of that. So you get some information about that. Okay, by the way, what we are dealing with, how many variables and what experimental units are. So the school administrators were the experimental unit, and what you do is what you ask them a single variable, that is rating, and the value of the rating would be either A, B, or C. So that is actually a univariate data. Another example, we have raw data for colors of the 21 candies. So you did an experiment in which you just notice the different colors of the candies. So you record some candies are of brown color, some are red color. You just put them as a data. But this data is how meaningful this data is. We don't get any idea. So what we do is we make it a tally sheet. So for example, we make the category called brown candies, and we make it a tally sheet like just counting it. So 1, 2, 3, 4, 5. The cross one is 5, and then there is 6. So the frequency becomes 6. Similarly, for counting the green candies, and altogether the sum must be 21 because we are counting 21 candies. So we are just categorize the data into different groups. Brown color candies, green color candies, orange candies, yellow, red, and blue. So this data is actually called as a group data, and the number of candies which are of different categories, that would be called as a frequency, and the sum of frequency must be equal to the total number of an observation. Okay, what sense we can do is we can just refine this data into more meaningful form if we just put a relative frequency. So out of 21, 6 are, so 28% candies are of brown color, 14% are of green color, and 24% are of blue color. So once you put the data in this tally sheet form, it is more meaningful than this raw data. Or you can plot that data, and you can see most of the candies are of brown color and blue color, and there are very few candies of yellow and red color. So this bar chart of the same data gives us more meaning to the data, and this is what the subject of statistics is all about, making more sense out of that data and look for the distribution of the data, how the data is being distributed. So, and this we will do it in the whole course. We will be doing that. So at this point we stop that lecture.